Good morning, students. Good morning, students. Today we are going to discuss next chapter, that is area of parallelogram and triangles. In this chapter today we are going to discuss the theorems and few points to remember. So the first theorem that we have, parallelograms, the same base and between the same parallel lines are equal in area. So suppose we have a parallelogram A, B, C, D and P, Q, C, D. So we have two parallelograms A, B, C, D and P, Q, C, D are two parallelograms where the base is same. The same base is CD. They lie on the same base CD and same base CD and same parallel lines. The same parallel lines is AQ, the full parallel line. This full parallel line is parallel to CD. So the parallelogram ABCD and PQCD lie between a same base, that is CD, and between same parallel line, that is AQ and CD are parallel. Then their areas, the area of ABCD and the area of PQCD are equal. The next theorem that we have, two triangles on same base and between the same parallels are equal in areas. So suppose we have a triangle ABC and PQC. Triangle ABC and triangle PBC are two triangles having same base. Same base is BC and same parallel lines are AP parallel to BC. So AP is parallel to BC. These lines are given and the two triangles are of same area if they lie between same parallel lines and same base. The third theorem and the last theorem of this exercise or this chapter is, two triangles having same base and equal area lie between same parallel lines. So again we are going to draw a triangle. This is ABC and suppose PBC. So the triangle ABC and triangle PBC, it is given that they lie in same base. They lie in same base. The base is BC. This is the base. And it is said the areas are equal. The area of ABC is equal to area of PBC. So it is given. When this two condition is given, we can say that the triangles lie between same parallel lines. Same parallel lines. The parallel lines are AP is parallel to BC. So we can conversely say that AP is parallel to BC is the converse of the first theorem, that is theorem 2. Now we will go by some points to remember. Some points to remember are, two figures are said to be on the same base and between same parallel lines if they have a common base and the vertices or the vertex opposite to the common base of each figure lie on a same parallel line. So the first theorem or the second theorem that I have explained, that whether it is a parallelogram or a triangle, if they lie between the same base, the base is fixed for both the parallelograms or both the triangles, and their vertices, which is lying opposite to the base, should be between the parallel lines. If I draw a figure and explain, then I'm taking the same example as before. So A, B, C, D is one parallelogram and P, Q is the other parallelogram. Here A, B, C, D having a common base CD and P, Q, C, D also have a common base CD. So the base is fixed and the vertices, that is A, B and P, Q, lies on the same parallel line. So we can say the areas are equal. Then again, the next point to remember is parallelogram on same base and between same areas are equal in areas. This is one of the theorem that we have gone through. If area of a we need to know how can we achieve area of a parallelogram. So area of a parallelogram is the product of the base and the corresponding height. That means if ABCD is a parallelogram, the base is CD and the corresponding height will be AD. So this is, by their product we can say that this is the area of the parallelogram. Now parallelogram on same base having equal areas lie between same parallel lines. We have done this theorem. This is the theorem 3 with triangle. So it is also true for parallelograms. Whenever it is mentioned that there are two parallelograms present which have a common base and their area is equal, so we can conversely say that they lie between same parallel lines. The straightforward proof is same base, same parallel lines, so areas are equal. If conversely it is given that same base and equal areas, then we can say that they lie between same parallel lines. This then the last some points to remember of this page. The last one is, if a parallelogram and a triangle are on the same base and between same parallel lines, then the area of the triangle is half of the area of the parallelogram. Now this is one of very important point to remember, since we will come across sums with this. So if ABCD is a parallelogram and PQCD, PCD is a triangle, so they lie between same parallel lines. The base is common, the common base is CD, and they lie between same parallel line, that is AB and CD. So we can say that the area of the triangle PCD is equals to half of area of the parallelogram ABCD. So this one point to remember, we will use many time in this exercise, so it is very important. Then there are last four points to remember are like this: triangles on same base and between same parallel lines are equal in areas. So triangles having the same base and between same parallel line have equal areas. So this one is the theorem number 2 that we have come across. Now how to find area of a triangle? So area of a triangle is the half of the product of its bases and the corresponding height, that is area of the triangle is half BH. This is the formula for right angle triangle. This can be used over here for all the triangles, where half is the numerical value base and its corresponding height. If all these three are is in product form, we will get the area of the triangle. Then the next point to remember is triangle on the same base and having equal areas lie between the same parallel lines. So this is our theorem 3 that we have come across, that whenever there are two triangles and these two triangles have a common base and the areas are equal. So we can conversely say that they lie between same parallel lines. And the last and important point to remember that we will use in this chapter quite often is median of a triangle divides it into two triangles of equal area. Suppose we have a triangle ABCD. So ABCD is a triangle and AM is the median. Then it divides the triangle into two triangles. So ABCD is divided into two triangles ABM and AMC. These two triangles will have equal areas if the triangle is divided by the median. So this is another theorem that we will, this is another point to remember that we will come across in this chapter quite often. So this is for today. All the points to remember for area of the parallelogram and triangles and some theorems in this chapter. I hope this tutorial is helpful for you. Thank you.